Okay, so this is a question on the higher tier paper. Question 1. A camera in a mobile phone uses an LED to provide light when taking a photograph. A student investigated how the potential difference across an LED varies with the current in it. Figure 1 shows the circuit used, which is this circuit here. The student changed the circuit so the LED emitted light. So what they're talking about there, basically the LED is facing the wrong way. So they're saying they turn the LED round the other way or change the battery round to make it work. The current in the circuit was 290 milliamps. The power of the LED was 0.9 watts. Calculate the potential difference across the LED. Use your physics equation sheet. Give your answer to two significant figures. Right, this is quite an easy 5 marks this, okay? Quite a lot of marks for this question. So, first thing, any equations we use with electronics and electricity is amps. So when we look at the current, we need to convert milliamps to amps. So to do that, we divide by 1,000, okay? Because there's 1,000 milliamps in 1 amp, all right? So divide by 1,000, and there's our first mark. 290 milliamps divided by 1,000 gives you 2.9 amps. Second bit, what equation we're going to use? So we've got current, which is here, been given that, okay? We've been given power, so what equation from the equation sheet can we use to find potential difference? So there's different ways to do it. I'm going to show you which I think is easiest. We are going to use, here we go, 1 minute, power equals potential difference times current, okay? So all we'll do now, we'll literally substitute our numbers into that equation. So we've been given power, which is 0.98 watts. We're trying to find potential difference or voltage, and we've now inserted our current, which is 0.29 amps. Okay, another mark for that. So 2 marks so far. Next thing we're going to do is rearrange the equation to make sure we can find V. So remember, we have to do the same to both sides. So whatever we do to this side, we must also do to this side, as in any equation. So to get V by itself, the opposite of times by 0.29 is divide by 0.29. So if we do that to both sides, V times 0.29 divided by 0.29 gives you V, and then 0.98 divided by 0.29, that gives our balanced equation. So all we've done here, divided both sides by 0.29. There's another mark, okay? So already we've got 3 marks out of 5. Next thing, for our 4th mark, nice and easy, put on the calculator, and this is what we get. Okay, so our potential difference is 3.379 volts. Now, the question asks, give your answer to 2 significant figures. Okay, so to get our last mark, we need to put this potential difference as 2 significant figures. Okay, which is 3.4 volts. All right, if we look at this number here, we've got 3.3. The next number after that is a 7, so a 5 or above, and we round it up. So we've got 3.4 volts. There we have it, nice, easy 5 marks for that question. Right, key bits that people tend to miss out: not converting this. Okay, so not converting your milliamps to amps. And the last bit, not putting it into 2 significant figures. Right, as long as you can rearrange and you read the question properly, that's a nice easy 5 marks. Okay.